Hello and welcome to my channel. In this video we are going to solve an example on mensuration. The volume of a paper cone of radius 2.4 cm is 95.4 cm cube. So the volume of this paper cone is given. The paper is cut along the slant height from O to AB. So we are going to cut open the cone from the point O till the point AB. And then the cone is opened to form a sector OAB of a circle with center O. So we are going to cut open this cone from the point O to AB so that it looks like a part of a circle, which is a sector. Calculate the sector angle X, and the formula for the volume of the cone is given as V equal to 1/3 pi r square h, where r represents the radius and h is the height of the cone. Now from this given data we can see that the volume of the cone is given, the radius of the cone is given, but the height is missing from the given data. So we will start by finding the height of the given cone by using the given formula. So let us start substituting the values of the volume and the radius in the given equation. So we get volume as 95.4 is equal to 1/3 times pi times the radius is given as 2.4. So 2.4 square times height. So let us make height as the subject now and find out its value. So we have 3 multiplies with 95.4 and pi times 2.4 square goes to the denominator, and we can write it as pi times 2.4 square. So we have rearranged the given formula. So this gives us a value of 15.82 centimeter. So this is the height of the cone. So let us write down the height over here. So it is 15.82 centimeter. And we have the radius as 2.4. So if we look at the diagram, we can see that this is a right angle triangle from O till the center of the circle and till the point AB. So from this right angle triangle, we can find out the slant height, which is this length of the given cone. So let me draw it over here. So the height, the perpendicular height, we got it as 15.82. We have the radius as 2.4 given in the data, and we have to find the slant height. So we can use the Pythagoras theorem to find the slant height and write it over here as the hypotenuse square is equal to sum of square of the rest two sides. So it is 15.82 square plus 2.4 square. So this gives us a value of 15.82 square plus 2.4 square. So it is 256.0324. But we have to find the length, not the length square. So we are going to square root it and get the value of the answer. And that gives us 16.00, or we can round it off as 16. So we have the slant height now as 16 centimeter. Now once we have got the slant height of the cone over here, we can see that the slant height of the cone is nothing but the radius of the sector. That is, from the point O to AB, this was the slant height. So the length from O till point A, which was the radius of the sector, is now the slant height of the cone. So we have actually found out the radius of the sector, which is 16 centimeter. Now one more observation over here is the circumference of the base circle is going to be equal to the arc length of the sector. That is, when we open up the cone at the point AB, it opens up as the arc length of the sector. So we can write over here that the circumference of the circle is equal to the arc length of the sector. So let us write it over here. So circumference of the circular base of cone is equal to the arc length of the sector. Now the formula for circumference of the circle is 2 pi r, that is the radius of this circular base is equal to, so the formula for arc length of the sector is given as x over 360 degrees, where x represents the central angle of the given sector, times 2 pi times the radius of the sector. Let me take it as r2 and this one as r1. So here we have the radius of the circular base as r1 and the radius of the sector as r2. Now let us start substituting the values over here to find the value of x. So we can see that the 2 pi's will cancel from both the sides, that is they divide each other, 2 pi and 2 pi. So let us rearrange this formula and make x as the subject. So we have x is equal to 360 multiplies with r1, then r2 goes to the denominator. Here we have 360 times r1 was the radius of the circular base, which was 2.4, and r2 was the slant height, which we had got it as 16. So let us put over here 16, and let us now calculate and see how much we get. So here it is 360 times 2.4, then it is divided by 16. So we have 54. So the central angle we got it as 54 degrees. Now let us look at the part B of this question. An empty fuel tank is filled using a cylindrical pipe with diameter 8 cm. Fuel flows along this pipe at a rate of 2 meters per second. It takes 24 minutes to fill the tank. Calculate the capacity of the tank, and we have to give the answer in liters. So I have drawn a rough diagram over here to give you an idea about the question. So here it's mentioned that an empty fuel tank is filled using a cylindrical pipe. So we have the cylindrical pipe over here, and it is filling a fuel tank, and the diameter of this cylindrical pipe is given as 8 cm. And the fuel is flowing through the pipe with the speed of 2 meters per second, and it takes 24 minutes to fill up this tank. So here we can understand that the volume or the capacity of the fuel tank will be equal to the volume of the cylindrical pipe, that is the amount of fuel that flows through this pipe. So we can write here as capacity of the fuel tank, or the volume of the fuel tank, will be equal to the volume of the cylindrical pipe, and the volume of cylindrical pipe is given by the formula base area times height. So this is the base of the cylinder, which is a circle. So the base area of the circle is given as pi times r square, and we do not know what is the height of the cylinder because it is not mentioned directly the height of the cylinder, but we have been given some hints in terms of rate and time. So let me write it over here as height, and we will find out later what is the height of the given cylinder. Now here the first thing we need to see is the radius. The diameter is given as 8 cm. So radius we have over here as 4 cm, that is half of the diameter. Here I am going to convert it into meters by dividing it by 100. So we get it as 0.04 meters. I did this because in the question they have mentioned the rate as 2 meters per second. So I am trying to get all the units in terms of meters wherever possible. If you want to convert the rate into centimeters, you can do that as well. Convert everything into centimeters or convert everything into meters, either of the two. So I have converted all the units into meters over here. The next thing I am going to do is trying to find out the height of the given cylindrical pipe. To do that, I am going to use the rate and the time given in the question. So here to find the height, I am going to use the distance, speed and time formula, because the cylindrical height can be also looked at as the distance traveled by the fuel to move towards the fuel tank. So let me write it in terms of distance. So distance or height is equal to speed times time. Now speed is given as the rate. So here we can write it as 2 meters per second, or 2 times, time is given as 24 minutes, but the speed is in seconds. So I'm again going to convert this 24 minutes into seconds by multiplying the 24 with 60. So when I multiply it with 60, it turns into seconds. So this gives us a value of height as 2880 meters. So this is the distance, or this is the height of the given cylinder. Now let us substitute the radius value and the height in the given formula for the capacity of fuel tank. So we have the capacity of fuel tank as pi times r, we got it as 0.04, so 0.04 square, times the height, we got it as 2880 meters. So let us find it out how much we get. So that gives us a value of 14.476, or we will round it off as 14.48. So this is 14.48, and this is cubic meters, because the radius also was in meters and the height also was in meters. But they have asked us to find the volume or the capacity in liters. So we have 1 cubic meter given as 1000 liters. So if we have 14.48 cubic meters, we are just going to multiply it with 1000 to convert it into liters. So that is going to be equal to 14,480 liters. So this is the capacity of the fuel tank, which is also equal to the capacity or the volume of the cylindrical pipe. I hope you have understood all the steps and liked the video. So if you're liking my videos, like, share and subscribe to my channel, and thank you for watching.